this was question 3 from a previous British Mathematical Olympiad Round 2. It was a very nice question for me to solve, and I'll show my awesome solution. And so a sequence, yn plus 1 is equal to half 3 yn, where plus root of 5 yn squared minus 4, where y0 is equal to 1, prove that all terms in this sequence are integers. Now, this was difficult, would you believe it? It took quite a bit of thought, but I enjoyed it. So if you multiply both sides of this equation by 2, you get 2yn plus 1 is equal to 3yn plus big root 5yn squared minus 4. And so if you subtract 3yn there, 2yn plus 1 plus minus 3yn is equal to big root 5yn squared minus 4. Now if we square both sides, we get 4yn plus 1 squared plus 9yn squared minus 12yn plus 1 is equal to 5yn squared minus 4. Now, if we subtract 5yn squared from both sides, we get 4yn plus 1 squared plus 4yn squared minus 12yn yn plus 1 is equal to negative 4, right? And notice how we can divide both sides of this equation by 4. So yn plus 1 squared plus yn squared minus 3 yn plus 1 is equal to negative 1. Now here is where I kind of reached a point of not really being able to get much farther in this problem, because it's got to have something to do with factorising. I worked that out and got here quite comfortably. However, I just didn't really know how to prove that they're all integers from here, right? I probably want 0 there. But then it occurred to me that if we have this equation, just logically speaking, if we replace n plus 1 with n and n with n minus 1, we could have yn squared plus yn minus 1 squared minus 3yn minus 1 is equal to negative 1, right? And because they both have yn, we can kind of like do some funny subtractive stuff to cancel those out and get rid of those. So if we subtract this equation, let's call that 1, let's call that 2. If we do 1 minus 2, we have yn plus 1 squared minus yn minus 1 squared minus 3 yn plus 1 plus 3 yn minus 1, right? Oh, is equal to 0. Now, this felt factorisable, right? So first notice difference, 2 squares here. So yn plus 1 plus yn minus 1, yn plus 1 minus yn minus 1 plus 3yn minus 1 minus 3 yn plus 1 is equal to 0. Now, surely we can factorise that as well. Of which we can. So, yn plus 1 plus yn minus 1, yn plus 1 minus yn minus 1 plus, now 3n goes into these, so 3yn minus 1 minus yn plus 1. Now, what have we got here? We have got that. That is very similar. And so if we multiply that by minus 1 and that by minus 1, the result would stay the same. So yn plus 1 plus yn minus 1, yn plus 1 minus yn minus 1 plus minus 3yn, yn plus 1 minus yn minus 1 is equal to 0. Now notice how that and that are the same. So we can kind of, if we just call that x, right, or whatever, actually don't do that, we can factorise it. So yn plus 1 minus yn minus 1 multiplied by then that term, so yn plus 1 plus yn minus 1 minus that term, so minus 3yn is equal to 0. Now that gives us, notice how we don't need the brackets there. It's just, I put that there for there in case we did, but we don't. Either that has to be 0 or that has to be 0. Now let's deal with that first. How can we prove that it is an increasing sequence, or this increases? Now this is quite clever. So if we write here yn plus 1 is equal to 3 over 2 yn plus half big root 5yn squared minus 4. Now, because of the root and stuff, we know that's got to be positive. And so if we add a positive number, that will be bigger. And because we have 3 over 2 yn, we know that that has always got to be bigger than yn. So we know that yn plus 1 minus yn minus 1 cannot be 0, because they are, that will always be bigger than that, right? And so we can form the equation from this. What is this? Yn plus 1 plus yn minus 1 minus 3yn is equal to 0. And so if we have yn plus 1 is equal to 3yn minus 3yn minus 1. Oh, sorry. yn minus 1, right? Now, ifyn's an integer and yn minus 1 is an integer, that has got to be an integer, because you're doing an integer subtract an integer. So we know that y0 is equal to 1, and yn plus 1, if we go back to the original equation, thingy iteration, is half 3yn plus square root of 5yn squared minus 4. So y1 is equal to half 3 times times 1 plus square root of 5 times 1 squared minus 4, which is half 3 plus root, that's 5 minus 4 is 1. So it's equal to half times 4, which is equal to 2. So y1 is equal to 2. And so yn plus 1 is equal to 3yn minus 3yn minus 1. Or let's just make those y's bigger. So y2 is equal to 3y1 minus, why have I put a 3 there? y0. y2 is equal to 3 times 2 minus 1. y2 is equal to 5, which is indeed correct. And because those are integers, that means that is an integer. I thought this was quite a fun problem to have a go at. I enjoyed it. And so, yeah. Goodbye.